Okay, we are reviewing in this video, we're reviewing one section, topic 1.2, which is motion, but we will be reviewing it in a bit advanced version, and basically we'll be focusing on graphs of motion. Okay, so basically there are one, two, three, a few graphs that you need to, these are the few graphs that need to be on your fingertips. There's one, two, three, I believe there are 16 altogether. Four, five, six, seven, and eight. So 8 times 2 would be 16. There are 16 graphs altogether that you must know the shape of. You must know their shapes, and if you know their shapes, you can tackle almost every graph of motion question. Okay, let's see. Number one is rest. So in the first column, we're going to have distance time graphs. In the second column, we're going to have speed time graphs. So how is rest represented in the distance time graph? Rest can be represented like this. For example, the body is over here. That's rest. Or your graph can look like this. That is also rest, which means the body is standing at any distance, for example, right, at a distance of, let's say, 5 or 6. And as the time goes by, the distance is 5, is not changing. Hence, uh, you can use this graph to represent it. I mean, I'll draw another graph for this. Either like this, or it may look like this. What's wrong with this? It may look like this. Um, like this. Okay, on a distance time graph. But on a speed time graph, it's always going to be over. In fact, I should use a different color. Yeah, on a distance time graph, on a speed time graph, it's always over here, which means that when the body is at rest, the speed is 0, and hence you'll have your graph over here, which means it is at 0. The speed is 0. Make sense? You notice the difference between the two types of graphs for the rest. Okay, how is uniform speed represented? Uniform speed is represented like this on a distance time graph, right? While on a speed time graph, uniform speed is represented like this. That's how a horizontal line represents a uniform speed. Uniform acceleration is represented like this, a graph going vertical, right? A graph that is moving upwards, we say the graph is going vertical, right? While a uniform acceleration is represented like this on a speed time graph. Increasing uniform acceleration is represented like this, the same as uniform acceleration, while increasing uniform acceleration is represented like this, going upwards. Decreasing uniform acceleration, again, it's like this for distance time graph. For decreasing uniform acceleration for a speed time graph, looks like this. Uniform deceleration looks like this on a distance time graph, while uniform deceleration looks like this on a speed time graph, a straight line with a negative slope. A decreasing uniform deceleration looks like this, while an increasing uniform deceleration looks like this on a distance time graph, going vertical but in the downward direction. Whenever there's something increasing, it's always going vertical. Okay, do you see this? Increasing, going vertical. Okay. Decreasing, going horizontal, right? In this case, this is increasing, so it's going vertical but downwards. And this is going to be vertical but downwards. How would it look like? This is going to look like this. Going vertical but in the horizontal with the downward direction would look like this. Well, this will again on a distance time graph. If you notice, all the decelerations on a distance time graph look the same, right? Whether it's uniform, non-uniform increasing, and non-uniform decreasing, all the accelerations look the same, whether it's uniform acceleration, non-uniform increasing, or non-uniform decreasing, but there's a difference in the slopes for speed time graphs. These 16 graphs should be on your fingertips, because I'm just about to use these in a in different questions. Next we have is three very, very important statements. How do we measure slope? Slope is y2 minus y1 divided by x2 minus x1. And slope of the, or gradient, you can also call it gradient. The gradient of a distance time graph measures speed. This is something you need to know. And the slope of the speed time graph measures acceleration. While area under a speed time graph measures distance traveled. These 16 graphs and these three facts are really, really important for tackling past paper questions. I think let's move on to past paper questions. Number one, the speed time graph shows the movement of a car. What does the shaded area represent? Well, this is a speed time graph, right? Speed and time. And because this is a speed time graph, then the average represents the total distance traveled by the car. We just saw it, right? Because we're talking about the shaded area, and area under a speed time graph represents distance traveled. A stone is dropped from top of a ladder. It falls and it hits the ground. It does not rebound. What is this? Which speed time graph is correct? Okay, so first stone falls. Initially, the stone was at rest, right? Initially was at rest. It falls, of course, it accelerates. Okay, which means it gains speed, right? And suddenly it stops, it hits zero, and suddenly speed is equal to zero, which means it comes to a rest. Okay. Now let's carefully analyze each graph. This graph represents uniform acceleration, which is true, but after that it represents constant speed. This is constant speed. While in our case, the ending point is rest. Okay, so this part is incorrect because it does not represent rest, but rather represents constant speed. So A is incorrect. Let's take a look at the next one. Initially, it says initially the speed is constant. Well, that is not true. Initially, it accelerates. Okay, so this is incorrect. The B would be incorrect. Let's take a look at D. This shows uniform deceleration, right? And it shows initially it had a certain speed, while we know that initially the speed was zero. Initially the speed is zero. So, and this is non-uniform deceleration, but our stone accelerates. Okay, not decelerate, so D would be incorrect. If you notice number C, this is acceleration, uniform acceleration, and then suddenly the speed is, because when it hits the ground, the speed is equal to zero, and hence this shows instant deceleration, so C would be the correct option. Okay, make sure you analyze this very, very carefully. Next, a car accelerates from traffic light for 10 seconds. It stays at steady speed for 20 seconds, right? So 0 to 10, it accelerates. Then 10 to 30, because for the next 20 seconds, it steady speed, which means constant speed. And 30 to 33 is deceleration because it applies brakes and decreases speed until it reaches rest. And at 33, speed should be equal to zero. This is the graph that we should look at. Okay, take a look at number one. 0 to 10 should be acceleration, while this is acceleration only from 0 to 3 or something, right? So A would be incorrect. Next is it accelerates, right? Well, let's take a look at number C first. 0 to 10, so from 0 to 10, it accelerates, okay? From 10 to 20, it says from 10 to 30, steady speed, while this showed the steady speed for only 10 seconds, while we know that steady speed was for 20 seconds. Okay, so this part is incorrect. If you look at C, it shows increasing acceleration, and then sudden deceleration. It does not show the steady speed in the middle. Steady speed is represented as a horizontal line, so D would be incorrect. Okay, let's take a look at B. So this is non-uniform acceleration, initially increasing and then decreasing. But this is acceleration up until point 10, right? 0 to 10 is acceleration, yes. For the next 10 to 30, it is constant speed, yes, because you have your horizontal line. So this is correct, right? And then deceleration from 30 to 33, so it's going downward until it reaches a speed of 0. So all of these options are correct, and hence option B is correct. Okay, this is acceleration, constant speed, and deceleration. Okay, hence option B would be correct. The graph shows a part of a journey made by a cyclist. How far did the cyclist travel in seconds? So this is a speed time graph, right? And how far means we need to work out the distance traveled. And how do we work out the distance traveled? By solving for area under the graph. Okay, so we need to work out all of this area, uh, all of the area beneath the curve. How would we work this out? I'll approach this very, very carefully. I need to work out all of this area, all the shaded area. Can I divide this into two sections? I would say this rectangle is A and this triangle is B. Let's work out the area A first. The base is 7 from here to here. It is 7, right? And the height is 4. This is 4. So area would be equal to length multiplied by breadth. In this case, 7 multiplied by 4 is 28 meters. Let's work out the area of triangle B. So if you carefully notice, how much is this length, base of the triangle? Base starts at 5, right? Ends at 7, so the base is 2. And the height is also 2, right? Starts at 4, ends at 6. So 1 by 2 multiplied by 2 multiplied by 2, in this case is going to be 2 meters, right? So total distance traveled would be 28 plus 2, which is going to be 30 meters is your answer. Make sure you do that very, very carefully. Right. If you want, I can draw these shapes over here. This rectangle is 4 and 7, while this triangle is 2 and 2 from this side, and you can work out the areas. Right. Let's approach this very, very quickly. In fact, let's take a look at the graph. I'll read the question later. I want you to be able to analyze all the sections of the graph. This is a speed time graph. What does this represent? I'm going to label these points and label these points A, B, C, D, E, F, and G. This is a very good thought exercise. I would say give it a pause and try to label all of these sections by yourself. AB, BC, CD, DE, EF, and FG. Try to label all of them by yourself. We just saw all of the shapes of the graphs. Okay. AB is a graph that's going vertical. So this is non-uniform acceleration and increasing one. Non-uniform acceleration and it is increasing. Okay. B to C is constant speed because this is a horizontal line. So you'll have a constant speed. C to D is uniform acceleration. So it's this. And this is this, then this, it's C to D is this. D to D is uniform deceleration, right? E to F is non-uniform deceleration and decreasing one actually. And F to G is uniform deceleration. Okay, these are very, very important parts of the graph that you need to tell by just by looking at the shape. The speed time graph represents the journey of a car. The dots separate the different sections of the journey. There are 6 different sections. How many sections represent the car moving with non-uniform acceleration? So non-uniform acceleration, first of all, is first one. If you carefully notice, EF is also non-uniform deceleration. Deceleration is the same thing as negative acceleration, right? So I can say this is also non-uniform acceleration, right? I mean, non-uniform negative acceleration to be precise. So how many sections? 2 sections represent non-uniform acceleration. If you notice, the rest of them either represent constant speed, they represent constant speed, or they represent uniform acceleration, or uniform deceleration, or again, non-uniform deceleration. Okay. Only 2 sections represent non-uniform acceleration. A cyclist travels along a hilly road without using pedals or brakes. Uh, Air resistance and the friction are negligible. The speed time graph of the cyclist is shown. At which point did he first reach the bottom of the hill? Did he reach the bottom of the first hill? Let's do that very, very carefully. So initially it accelerated, then it started moving at a constant speed, right? Then it moved at a constant speed, and this is the point where it like accelerates uniformly, and then this is the point where it comes to a rest. Okay, and then it um, comes to rest. Then it of course climbs up. So as it climbs up, the speed goes down, and at point C, it comes to rest again, which means it has hit the top of the first mountain, and so on, right? So bottom of the first hill is the point where is the speed is. Think about it this way, right? So the car is a cyclist is traveling like this, for example, and here is the hill, like, and then there's the hill. So initially, when the cyclist is moving, it looks more like a robot. It gains speed, right, till it reaches constant speed. Then, as it goes down, the speed increases very fastly, right? So this is represented by fast increase in speed, and this is the bottom, right? At the bottom, when it reaches the bottom, it comes to a rest for a while, and when it goes up, the speed decreases. Okay, so B is the correct option. This is the point where it comes to a rest for a brief while and then starts climbing the first hill. A ball starts to roll down a steep slope and along a rough horizontal road. Which graph shows the speed of the ball? Okay, rolling down a steep hill. Okay, so this is, let's say, a hill, right? And then along a rough horizontal ground like this. Okay, so initially when the ball rolls down, the speed increases. Okay, so initially it's graph B says the speed is constant initially, so graph B would be incorrect, right? And speed increases for a while, right? When it reaches over here, and then when it rolls along, it eventually reaches constant speed, and the speed begins to decrease because it's a rough horizontal ground. On a rough ground, the speed decreases gradually due to friction. Okay, so which means the speed begins to decrease. The ball will begin to decelerate. Um, the ball will begin to decelerate, right? So increase in speed, right? So graph A, why is this graph A incorrect? Because there is an increase in speed, which is correct, but afterward it shows constant speed. The graph is The speed is not constant on a horizontal ground, but rather the speed decreases. So A would be incorrect. A graph says that there's increase in speed, which is correct, but rather after that, it comes to rest. It doesn't come to rest right after. Like, it travels along, it goes on and on till the speed decreases. So D would be the correct option because it represents acceleration, and afterwards there shows a gradual decrease in speed. So D would be the correct option. Right. The speed time graph for a car is shown. What is the acceleration of the car at 30 seconds? Let's see. So at 30 seconds, if you notice, we talked about this before as well. At 30 seconds, if you remember, the slope of the speed time graph measures acceleration, right? So at 30 seconds, if you were to take the slope of the graph, at 30 seconds, the slope of the graph is this, horizontal. And we know when the slope is horizontal, the gradient, the slope is equal to zero. Right? This acceleration is going to be zero. At 30 seconds, the acceleration is zero because the slope is zero. The diagram shows the speed time graph of the motion of the car for 4 seconds. What is the distance traveled by the car in 4 seconds? Which means we need to work out all of the area. I'm going to call this area A, and I'm going to call this area B. So for area A, this is 1, length is 1, multiplied by height is 10, so it's going to be 10 meters. B is a triangle, and the base of the triangle starts at 1, ends at 4, so the base is 3, and the height is 10. So 1 by 2 multiplied by 10 multiplied by 3 is going to be 15 meters. Total area is equal to 10 plus 15. It's going to be 25 meters. So B is your answer for the total area under the graph. Right. The graph shows how the speed of the car traveling in a straight line changes with time. Which section shows the largest acceleration? Interesting. A shows acceleration, yes, uniform acceleration. B also shows uniform acceleration, but if you notice, uh, it's not as steep. So which one is, and this one is very, very steep, but this is deceleration, but A is the steepest, right? If you remember, we just talked about this. The slope of the speed time graph measures acceleration, right? So greater the slope, the greater the acceleration, right? This one is smaller slope. This one is zero slope, smaller slope, greater slope, greater slope, greater slope, right? So if you compare A and B, the slope of A is greater than the slope of B. So definitely A would be your answer because it shows the largest acceleration because of the greater slope. A has greater slope. Next, the speed time graph represents a short journey. There's a speed time graph. What distance time graph represents the same journey? I think for this, you can simply refer to the graph that I've just showed you. This represents uniform acceleration, right? And all the accelerations on this the distance time graph are going vertically upwards. So A would be your answer. This is deceleration on a distance time graph. This is constant speed on a distance time graph, and this is rest on a distance time graph. This one, number A, is the acceleration. If you want, I can show you over here. Here. Uniform acceleration on a speed time graph looks like this, but on a distance time graph, it looks like this, going vertical. So this is what we are talking about. Right, A is your answer. Let's move on to the next one. A cyclist takes a ride lasting 25 seconds. So total time is 25 seconds. Diagram shows her distance traveled from the starting position varies with time. How much is the distance traveled? Total distance traveled is 150 meters. So total distance equals 150 meters. Total time is 25 seconds. I'm going to write total time equals 25 seconds. What is the average speed of the whole ride? Well, this is simple. We know that average speed equals total distance over total time, right? Total distance is 150 divided by 25. It's going to be 6 meters per second. You can work it out on your calculator. 150 divided by 25. Let me double check. 150 divided by 25 is a 6 meter per second. 6 meters per second. Next, the distance, a graph travels at a constant speed for 10 meters, at 10 meters for 10 seconds. In the next 5 seconds, accelerates uniformly at 20 seconds. What is the total distance traveled by the object? Okay. I think the numbers have changed, but it's a question we've done before. I'm going to call this A. I'm going to call this B. Total distance traveled, area would be. So this is a rectangle that has the bottom of 15 and the top is 10. So 15 multiplied by 10 will be 150 meters. For B is a triangle, right? If you carefully notice, the base of the triangle is 5 and the height of the triangle is starting from 10 and you get 20. So this is going to be 10, right? So 1 by 2 multiplied by 5 multiplied by 10 is going to be 25 meters, right? 50 divided by 25, yes. So A plus B total distance would be equal to 150 plus 25. Altogether, it should be 175 meters. B is your answer. The graph shows how the car varies with time. The speed of the car varies with time. Which statement about the acceleration of the car between 10 second and 20 second is correct? So if you notice, between 10 second and 20 second, this is constant speed, right? We're talking about this region of the graph, right? This region of the graph. We're talking about this region of the graph between 10 second and 20 second. If you notice, whenever you have a constant speed, can I say no change in speed? Because the speed is not changing, right? Which means acceleration is going to be 0, right? Whenever there is no acceleration is the rate of change of velocity, right? So if there is no change, there is no acceleration. The acceleration is 0. B will be the correct one. Acceleration does not decrease or increase. Acceleration is 0. So D is your answer. Shows the distance time graph of the car traveling in a straight line. In which region is the car accelerating? Okay. If you notice, this is going up. Okay. A is going up. If I were to draw this region separately, A is going up. This is region A. Region B is a straight line. Region C is a curve that is going horizontal. This is region C. And region D represents rest. Region D is just a horizontal line. Okay. Now I would encourage you to go back to the graphs and see what each of these means. If there's a graph that's going upwards, which means that is acceleration. If it's a graph that's going, if you're talking about distance time graphs, if there's a graph that's straight, it's a straight line with a positive slope. This is a line that represents constant speed. And there's a graph that's going horizontal, which means that this represents deceleration. So the answer is going to be C, because it represents deceleration on a speed time graph. A car has stopped at a red light. When the light changes to green, the car starts moving with a constant acceleration. So on a speed time graph, constant acceleration looks like this. Okay. But on a distance time graph, constant acceleration looks like this, right? So constant acceleration, which means this is definitely a distance time graph. On the y-axis, there should be a distance. On the x-axis, there should be time. Okay. So on y-axis, it should be distance, and on x-axis, it should be time. The answer should be C. Okay. The diagram shows the speed time graph for object moving with uniform acceleration. What is the distance traveled in the first 4 seconds? This is really simple. You only have to work out this area, right? How would you work out this area? This is a triangle, of course. Base is 4 and this is 6. So distance travel will equal to area under the graph, which is area of the triangle, which is 1 over 2 multiplied by 4 multiplied by 6, which is going to be 12 meters. You can work it out in the calculator and you will get 12 meters. So 12 meters is your answer. Okay, I hope it makes sense. This is about uh, basic graphs of motion and mostly just identification from the shape of the graph. I hope we'll see you in the next session.